The need for understanding where everything came from is the core of human society. Modern science has led us down paths of discovery, growing that ever-changing understanding. It has guided our cultures and has steered humanity into an era full of possibility. The achievements of humanity are far-reaching, and some are reaching farther with every second that passes. Humans are gathering information about the world or worlds around us at a staggering pace, and with every step, we are that much closer to becoming something great. In a brief history of modern science, while looking at the pillars that hold it up, many names are found. Planck, Bohr, Heisenberg, de Broglie, Einstein, Schrödinger, Fermi, Pauli, Thomson, Rutherford, Faraday, and others unmask this wealth of knowledge that has guided all of us to where we stand today. However, if we want to fully cover a historical journey through modern science, we must turn the dial back further in time. We must turn past Newton and Leibniz and focus on ancient Greece. Though we use the term modern science when we consider our ideals when assessing the world around us, the ideals are not modern in the least. 2,500 years ago, Parmenides entered an argument that would echo throughout history. It would be this thread that ties us to our ancient past, ringing an echo still heard today. Out of nothing, nothing comes. This statement changed the thought process of all of those to come, and modern science will be built upon this thought. Interestingly enough, a counter-argument would be created not long after Parmenides. On the Indian subcontinent, a new numerical system was invented. This new way to quantify would struggle out of the gate, but would later encompass the entire planet. Its ability to establish nothing would forever alter the ability to calculate. The first time zero is seen in the Western world is 976. Later, Fibonacci would return with teachings from the East that also contain the Hindu-Arabic numeral system. This would spur its usage in the West, finally being fully accepted around the 15th century. By this time, philosophers and mathematicians had already carved out what would become our understanding of the universe. Fast forwarding through the centuries and approaching back to modern day, philosophy is set aside and mathematics takes over for how we explain something to be logical. Zero, however, is forgotten and lost. This was a crucial mistake. Had philosophers considered a beginning while including nothing, one conclusion would have been found. Zero is the only beginning. Everything would have to be started from nothing. But how can this be? Science has backed quantum mechanics and this has flourished. As best we can tell, we are now closer than ever to unraveling the secrets of the universe. I must pause this thought and ask, are we? Are we really that much closer? Turning our attention to modern-day quantum mechanics, particle physics is split between multiple camps. Theories stacking and trying to make sense of it all, dimensions stretching past the human conception, membranes and multiverses clutter a divided field, and all of this is sparking a question. Could something be wrong? Though I know this question itself almost seems unwarranted because, as I said, we have devised the most accurate system to date that continuously proves its validity. And against this, I do not argue. Quantum theory is the most accurate system ever invented to explain the workings of the cosmos on a small scale. It is against the framework that I argue, for us to be able to predict in the fashion we do, there has to be partial correctness to the theory. However, our inconsistencies show that there is something missing or wrong. In 1935, Einstein, Podolsky, and Rosen introduced an argument. This argument asked if there could be something missing. An argument that would make quantum theory stumble, but would not win in the end. Einstein would finish his days trying to find what this could be and what the unifying answer was, with no avail. I stand here today to tell you they were right. If we add zero to our explanation, it corrects the wave function and adds a way to quantify the uncertainty. This is the missing piece. ZPF, quantum foam, quantum fluctuations, whatever you want to call it, may appear random, but the inclusion of zero shows it is not. Since I am arguing that philosophy and mathematics must be used in conjunction with one another again, then to show this idea's validity, I must provide both answers. There is one rule of nature that takes precedence over all. It is that perfection does not exist. So if nothing, or zero is the beginning, it cannot exist forever as it would be perfect. In turn, something has to come from it. Looking as a whole, if change is the only constant, then the infinity of nothing cannot escape this law. Philosophically, this may seem like a flimsy argument, not to mention the complexity of even considering how something can come from nothing. However, It is out of this basic principle we can build a universe. And I assure you, though this may seem like an absurd concept, there is a mathematical representation of it. After zero was introduced, mathematicians pored over the rules of the language. Calculating and revising, one of the greatest human inventions, encountered a strange occurrence while using zero. In exponential notation, there is an event that twisted the minds of all of those who considered the notion, and it was hotly contested and debated upon after its realization. In the end, reason dictated zero to follow the rules of all the others. 0 to the 0 power shows us that there is validity in the argument of a universe from nothing. An argument against the longest-standing scientific principle is able to be presented. Once this step has been achieved, the galactic cluster we now see can begin to take hold. Three-dimensional space is represented by 6 points, or 6 points of contact in relation to the particle, each birth instigating another. Propagation in this fashion also satisfies the three-dimensional homogeneous space without a flat universe. This is the beginning of the universe. All of matter and energy started from this point. Using basic mathematical properties, we can build something from nothing. Particle propagation will now expand at a rate of 6 to the x. As I said earlier, adding 0 as a beginning also clarifies what is occurring with quantum fluctuations. They are not popping in and out of existence, they are just popping into existence, and at a measurable rate. This also eliminates the need for multiple dimensions, membranes, and etc., as it provides the potential energy without a reservoir. This first particle is dark energy. So, dark energy will be created at a rate of 6 to the x anywhere there is contact with true empty space or nothing. That means from the edges of everything to the space between spaces, dark energy is being created. During the inflationary period, ever-filling space will create inconsistencies that begin to form a vortex. These pockets will be able to use expansion to create contraction. As these areas spin about themselves, it creates a low pressure. The outer field will be creating new particles more freely and more plentiful. This forces the spinning inconsistencies closer together, further impeding the creation of more dark energy. These pockets will go on to form dark matter, whose role will be vital in creating the rest of all of what we see today. The transition from dark energy to dark matter will be the step that creates the difference between expansion and contraction, the outflow of energy and the compression of gravity. Dark matter behaves differently because it has fused dark energy. This diminishes the potential area to create dark energy within the volume. Without this step, no other matter would be able to condense. I know I'm running long for a video, but for an explanation of the universe, 10 minutes is pretty short. However, if I cannot explain to you an answer such as this in 10 minutes, it's probably not a very good answer. And before we wrap this up, I want to pose a question for you. What if this is the answer? Should we casually dismiss it? Humanity may have a chance to change our future. With the right growth, this could ensure the survival of our species and all the generations to come, as this explanation will shed light on aspects of the cosmos not thought possible previously. Humanity will be able to take a step beyond our world and enter an age that defies conventional thinking. We are standing on the frontier of something entirely new. Before we get there, however, it starts here. This idea needs to be tested. Words are powerful and can invoke a sense of excitement, but they do not bear physicality. I want to prove to you that this is the answer, and that we can usher in a new era, one where we can utilize an understanding of the cosmos in ways never thought possible, and unlock the secrets of a universe from nothing.